Good morning, students. In the last video we have seen deadlock avoidance first method, that is a resource allocation graph, how we can use for the deadlock avoidance. In this video we'll try to see how Banker's algorithm can be used for avoiding the deadlock. Banker's algorithm is mainly used for the avoiding the deadlock or deadlock detection also we call sometimes. Let's try to understand deadlock avoidance or Banker's algorithm with the help of example. The same kind of examples will be asked in the question paper also. Consider the following system snapshot. Means this system is having 5 processes, that is P0, P1, P2, P3, P4. Then allocation is nothing but it is a matrix. All these 5 processes needs 3 types of resources, that is A type resource, B type resource, C types. Already we have discussed different types of resources will be there in system. In this example, these processes are requesting for 3 types of resources, that is one type is A, one type is B, another type is C. Allocation is nothing but when they come to the system, they will request some kind of resources of type A, some kind of resources for type B, and some kind of resources for type C. 0, 1, 0 indicates P0 is allocated with none of the A type of resources. P0 is allocated one type of B resource, and P0 is allocated with 0 number of C type resources. Then P1 process has been allocated 2 copies of A resource, 0 copies of B resource, 0 copies of C resource. In the same way, P2 is allocated with 302, then P3 is allocated with 211, P4 is allocated with 002. This is the initial allotment. But to complete the execution of P0 needs maximum of 753. That means to complete the execution of P0 needs 7 copies of A resource, 5 copies of B resource, and 3 copies of C resource. But how many system has already allocated? 0, 1, 0. That means only 1 copy of B it has allocated. Still how many it needs, we'll calculate later. Maximum means how many they need to complete the execution. Then P1, how many they need maximum to complete? 3 copies of A type, 2 copies of B type, 2 copies of C type. And P2 needs 9 copies of A type, 0 copies of B type, and 2 copies of C type. Means P2 don't need B type of resource, only they need A type 9 copies, C type 2 copies. Then coming to the P3 needs all 2 copies, P4 needs 433. So these are the maximum requirement of the processes they need in order to complete the execution. But how many we have given? Initially the system has given only this much. Then remaining, definitely P0 will request for the remaining resource, P1 will also request for the remaining resource, P2 also will request the remaining resource, P4 also will request the remaining resource. But coming to the available matrix 332, this means right now in system 3 copies of A resource are available, 3 copies of B resource are available, 3 copies of 2 resources are available. Sorry, C type 2 resources are available. After allocating the initial allotment, this many are available, but system needs this many allotment to complete the execution of all these processes. So in order to proceed, we have total 3 matrices. One is allocation matrix, another one is a maximum matrix, another one is available matrix. Allocation is nothing but when they come to the system, the computer will allocate this by default some resources irrespective of what they need to complete. Then system will also give you how processes also will give us how many they need to complete. For example, P0 needs 753 to complete. Then first we need to calculate, according to the question he is asking, find the content of the need matrix. Then second he is asking, determine whether the system is in safe state or not. We will see what do you mean by safe state. If a request for P1 arrives for the 102, can the request be granted immediately? We will see one by one. First we will try to solve the first one, that is need matrix. Need matrix is nothing but need matrix is equal to, we need to find out maximum minus allocation. So what we can do is we can calculate the need matrix of all the processes P0, P1, P2, P3, P4. Then A, B, C, because 3 types of resources we have. Then P naught means, now I have written the maximum minus allocation. Maximum is how much? 753. This many they need to complete the execution. P naught process needs 7 copies of A, 5 copies of B,